Hi, my name's Doug. Welcome to another Emerald Hills sky portrait. This sky portrait that we're looking at tonight is of Copeland Septet. For a long time, Copeland Septet was one of those missing galaxy clusters, missing objects in the night sky. It was a mystery as to where it was located. Tonight we're going to rediscover it. So let's get started. We observed from the outskirts of Louisville, Kentucky. Let's get started first by looking at our planetarium software. And that planetarium software is called Stellarium. So we'll get that up here on the screen. It's one of three major softwares we use in our electronically assisted astronomy suite. We use Stellarium, SharpCap, and AstroPlanner. So let's start with Stellarium. This will give us a good view of the night sky that we're looking at. Look down here at the bottom, you'll see the cardinal compass point of east, and over here is the cardinal point of south. So southeast is here. That means if you go outside and look due east and you work your way up toward the zenith, which would be straight up, then you're in the right ballpark when you pass by around, I don't know, at this time of night it's around 58 degrees up in the sky. A better way to find it is with the constellations. If you can find the Big Dipper, if you can find the Big Dipper, then follow the two bowl stars away from the open part of the Dipper, the open part of the bowl, the end stars of the Big Dipper, and they point eventually at this lion-shaped constellation called Leo. It's one of the few constellations in the sky that actually looks like what it's supposed to be, Leo the lion. Now it's pretty easy to find this right triangle if you use those two pointer stars from the back of the Big Dipper. You can find this right triangle, but then if you trace the body, you can go from Denebula here over to Regulus. Those happen to be pretty bright stars. And then, if you're careful, you can trace up in this form of a question mark. Look how the lion's head here makes a kind of a question mark. Is that the right direction? It's not, is it? It's a reversed question mark. Oh well, can't have everything right. And then you can trace the top of his body. So anyway, if you can find all that, then look at this right triangle at the back of his tail and draw a, what would that be called? Like bisect the hypotenuse, I don't know what that's called, toward this object that you'll try to look at here in the middle. But I got to tell you, this is a very dim object. In fact, it's a galaxy cluster made up of 7 galaxies, and they are all so faint. It's like 13th magnitude and fainter. The last one, in fact, is 15th magnitude. It's so faint that when Phil Harrington did his book, Cosmic Challenge, he puts Copeland Septet in the part of the book that's designed for monster scopes. And he classifies monster scopes as telescopes that are 15 inches and larger. So you got to have a pretty good size, like a Dobsonian or something, 15-inch and larger telescope. Now we're using an 11-inch RASA, but we are using electronically assisted astronomy with this ZWO ASI2600MC Pro here on the front of the scope. So we're kind of cheating a little bit. In fact, I worked with a developer recently. It's the developer for Sky Tools 4. His name is Greg. And in order for him to help us see what his software predicted that we ought to be able to see, we actually had to ratchet our telescope up to be a 32-inch telescope because we were using electronically assisted astronomy. And it threw his formulae all out of whack. So in other words, his software couldn't predict very well what our 11-inch RASA could see unless we told the software a bit of a white lie. We had to tell the software we're using a 32-inch telescope. So that should tell you what EAA, Electronically Assisted Astronomy, can do for your scope if you can get this running. So anyway, this is a part of the sky that we're going to go look at. So now let's go to the actual live view of the sky. And this is via a little ZWO ASI 178 monochrome camera that rides on top the scope in what we affectionately call an outrigger here on top of the Celestron RASA 11. And this little camera doesn't even have a telescope on it. It's just a 153 view, roughly, of the night sky. So let's go to that view, and let's do what we just did in the Stellarium planetarium software. Now this is a SharpCap. It's an instance of SharpCap looking at what that camera is seeing, the 178 monochrome. So here's the Big Dipper. And if we take the back two stars, like the stars of the bowl, and take it in this direction, here's that right triangle. Now this is a live view of the sky, and it's a pretty sky tonight. The moon doesn't rise until 11:36. We've got about 46 minutes left of absolute, well, light polluted Bortle 6 Louisville outskirts, but still, nevertheless, pretty black skies, comparatively speaking. Here's that right triangle, and if you trace from Denebula over to Regulus, now here's where we go up to the front of the lion. This is his front of his body, and this is where his mane starts, and that's his head. So remember, that's the backward question mark. So now you can find this in your night sky, I bet. Just use this trick of following the bowl stars in the opposite direction of the open part of the bowl, and you'll see the lion. Then, if you bisect this hypotenuse, is that what you call it in geometry? And you come out here somewhere, you'll find the location of where this Copeland Septet galaxy cluster is located. But I got to tell you, this is going to be a hard object. In fact, this was discovered, it was missed by Pierre Michin and Messier and all those early astronomers. It was missed by William Herschel. You know, not even Herschel in all of his glory could have found this. It wasn't until William Parsons' assistant, Ralph Copeland was the name of the assistant, actually discovered these 7 galaxies all in a little 5-minute arc, a 5 arc minute circle. An arc minute, that would be 1 arc minute is 1/60th of a degree. There are 180 degrees in the sky, you know, on the side that you can see. So this is a very tiny part of the sky. He didn't discover it till February 9th, 1874, and he was looking through a 72-inch telescope in Ireland. He was the assistant to William Parsons, who was the Earl of Rosse. I hope that's how you say that. At that time, it was the largest telescope in the world. Now, he was thrilled to find this. In fact, he was so excited that the story goes that he was so anxious to write down his discovery, so eager to write down his discovery, that he got the guide star a little bit wrong, and all 7 galaxies were written down incorrectly. And for years, nobody could find again what he had found. Isn't that crazy mysterious? It wasn't until, well, in fact, John Dreyer used his incorrect data, just banking on the fact that the Earl of Rosse's data was usually good, but poor Ralph Copeland had mistakenly noted it. And John Dreyer used his incorrect data when he made the new general catalog. So that was 14 years later. So for years, when subsequent observers tried to find these galaxies, they weren't able to find them. And it wasn't until years later, probably maybe the 1980s. Can you imagine? It wasn't until the 1980s that a guy named Paul Hickson included it for the first time correctly as his Hickson Galaxy Cluster 57 in a group of 100 compact galaxy groups that he listed in his Hickson index catalog. So this went on, keep in mind, until the 1980s. This was a missing object. So you still have a lot of astronomy books from the 60s, 70s, 80s that call this cluster missing. It's like a pirate ship floating out into the sea, into fog, you know, and nobody could find it again. Can you imagine? Well, tonight we're going to try to find it. So let's now go to our live view of from our actual Celestron RASA. And while we've been talking here and also setting up the video, about 30 minutes have clicked by. So when we go to this live view, and this is a SharpCap instance of the RASA 11. So you're looking with me through this telescope right now live, if you're viewing live. And if you're viewing in a recorded format, you're kind of watching what we looked at live. So now you can see why for many observers this was missing, because it doesn't look like there's anything in this field of view. But if you start zeroing in, little by little, you start seeing a tiny group of tiny galaxies. And sure enough, this is actually 100% of the imaging that we can do if we just rely on optical imaging with that ZWO ASI2600 camera. This is its limit by optical imaging, and it is an APS-C camera, so it's a pretty good size format camera. But that's how small this group is. It's only 5 arc minutes from edge to edge. But what we can do now is put the deep sky image annotation on, and you can see the little circles that will start giving us a clue. Yes, we're looking at the right galaxies. Now I've listed all these NGC objects in the description below. It's NGC 3745, 46, 48, 50, 51, 53, 54. So pretty almost consecutive. NGC 3745, 46, 48, 50, 51, 53, 54. Let's zero in with the deep sky image annotation on and use our what you might call digital zoom, if you want to call it that. And you can see that what Robin Glover has done here in SharpCap is given us a way to identify even the tiniest of galaxies. And we're so thankful that even such a tiny group, he is pulling in the NGC listings so we can get every single galaxy identified. Now, if you're making a sketch of these, I'm sure, isn't that what you do with every single sky portrait that we do? You can sketch them this way with 3746 up there in the upper right, and then 45 and 48. 46, 37, 46, 45, and 48. So let's look at those first. NGC 37, 46, 45, and 48. So let's turn off deep sky image annotation. So this is NGC 3746. Now look how you can see just a tiny bit of a spiral structure that we can sort of imagine there. It's just a breath. Let's see if we can brighten it up just a little bit. Not much, but a little bit. Can you see that you can even look at the pixel count? We can actually count how many pixels wide this galaxy is. Now, this is a very large format camera. This camera sees 6248 by 4176. I mean, it's like megapixels, you know, it's millions of pixels. But we're looking at 1 by 1 of those pixels. That's how small these galaxies are. So this, remember, is 3746, 45, and 48. Now, if you want to look at his sketch, you can see his sketch here in his book. This is Phil Harrington. 3746, 45, and 48. I had to actually handwrite 3745 in because he had left that out of his sketch for some reason. Still a mystery the way this pirate ship rode off into the fog. So those are the first 3. And then you get to the next 4. And looking at his sketch, you can see that circling on around, we have 54, 53, and 50. So this is 54, 53, and 50. Whoops, I need to give you the screen again. 54, 53, and 50. I think 53 is actually one of the poster child galaxies. If you look very closely, you can see a bright and a bulging core, just like the Milky Way has. And then you can see that it's an edge-on galaxy. You can see the arms on either side. So it looks like a flying saucer, doesn't it? It's really cool. And there's a little bit of stardust being thrown out here because these galaxies are interacting. And the tidal forces, that's T-I-D-A-L, like the tide has come in and it's mixing up this galaxy a bit. Now the last galaxy is the one that's, I take it out here, and that's 3751. So let's put, you can use Control-Shift-A, and that puts the deep sky image adaptation back on. There's 3751. So again, it's 46, 45, 48, 54, 53, 50, and then 51. So we're going to go over here to Astro Planner now, and we're going to say a quick observation. We're going to make sure that the little checkbox here is checked, and then we're going to say, cool that this galaxy cluster was, quote, lost for decades, I'm going to say, actually close to 100 years. After Ralph Copeland discovered it first on February 9th, 1874. February 9th, 1874. 100 years later, we finally found it again. Now when I click OK, it's going to, let's see, all crowded inside of 5 arc minutes. Beautiful group. Now when I click OK, it's going to make an observation for all 7 galaxies. In a moment. And then
observations for 7 objects logged.
There we go. And then we're going to go back and let's do a separate observation of 53 again and say, and let's unclick the checkbox and say, we noted that this galaxy looked like a flying saucer with a bit of a tailpipe exhaust problem. Its edge on magnitude 13.6. Okay, and the one that's 15.2 is 45. This one right here, which we have no trouble seeing at all. So let's go to 40.
Observation logged.
Let's go to 45, and let's just do a quick observation on that with the add associated objects unchecked, and let's say this galaxy is the dimmest, or faintest maybe is a better word, faintest of the 7, magnitude 15.2. But still no problem in the RASA. All right, now you might be thinking
observation logged
that we need 38 minutes to see these. By the way, I think what we'll do is, with it zoomed in like this, we'll do like a screen grab. And then we'll just call this, let's see, save as, and we'll put this in our, sharp cap captures. We'll say Copeland Septet, and it's at 38 minutes, which is the longest EAA session ever. 24, but it's just because it took us a while to get the video set up. and I'm going to say here cropped. Okay. You know, I'm also going to save that as a JPEG because I've messed something up in my, I haven't figured out how to fix it recently. Copeland Septet, 38 minutes, 39 minutes, 240328 JPEG. Yeah, I messed something up in my little, earphone or whatever this is called, earphone view, and it's not saving PNGs right. I just need to get into the configuration file and fix the PNG saving. So I'm going to say sharp captures Copeland Septet 38 minutes cropped, no annotation. Save it in JPEG. Wow, we're getting a really now nice view of NGC 3753 now. Look at that. It just looks like a flying saucer coming to a skidding stop. Isn't that cool? Pick up just a little too much sky glow grain when you bump up that vertical slider too high. But I just trust and hope that you're seeing that. That's at 200%. That's still really beautiful, isn't it? Let's go ahead and save exactly a scene now. So that saves the whole frame. So this will be a tiny, tiny circle in the middle of that frame. So this shows also how we use the three programs together, the three software pieces together in one EAA suite. So you've got your Stellarium, which is useful for getting a sense of what the night sky is going to look like. This shows you, all your constellations and where it's going to be located in the night sky. Kind of helps us see the context. And then you've got SharpCap, which gives you your view of the live view through your camera, through your telescope. So this is actually what the telescope is seeing right now, right outside, 200 feet outside of where I'm sitting, is this, roll-off roof observatory by Pier-Tech, and it's RASA 11 sitting on that adjustable height pier. We elevate the RASA up so it can look pretty much at 2 and 3 degrees above the horizon in pretty much all directions where there's not a tree or two. And then, so that live view you're looking at here, and then the third piece of software is over here. That's Astro Planner. And this suite is kind of the core of our operating EAA setup. I don't know what yours is like, but if you like content like this, I hope you'll subscribe. And that builds the channel, helps other people find it. In fact, if you like content like this and you've liked this sky portrait tonight, it would be awesome if you could click the thumbs up, and that helps other people find this video. And then if you would want to be notified, you can click that bell and put it to notify you in your YouTube video. And if you like to receive an email when we're going to do live streams, we usually don't email when we're going to do these little sky portraits because they're just little smaller bite-sized things. But for a 2-hour live stream, you can actually sign up at emeraldhillskies.com, the website, emeraldhillskies.com. And at that website, you'll see the place to sign up to be notified about 24 hours in advance whenever we're going to do a live stream. So thanks for joining us. Thanks for being a part of this community. And we hope to see you again later. During the live streams, we build a lot of community in the live comments. We hope you'll come back for that. And thanks to God for making these cool galaxy clusters so we can have things to look at in the night sky. And boy, are they amazing or what. So we'll see you again later. God bless. Good night.